I wish I could see. I can see you, Anoop. I can't see anybody else there, but and even more so, I wish I could be there with everyone. But here I am in my house in Cambridge because of teaching and other things. I wasn't able to join you all there. It's 2:45 in the morning my time. I'm going to give these remarks and then probably go to sleep and watch most of the really cool talks. Um, yeah, in the morning when I wake up. But I did want to say a few things at the beginning because this is a really exciting workshop. I'm really looking forward to the invited speakers and all the contributed talks and presentations. Um, and I think we all recognize that this is a really unique time with progress in computer vision, natural language processing, and various kinds of multimodal models, bringing these models together to try to tackle the thing that really in humans is in between perception and language, which is thinking or reasoning. And I want to just give a couple of examples, actually drawing on some of the most recent vision and language models that are publicly available, like GPT-4 and BARD and so on. Also drawing from some examples from this really nice paper that Anoop put together and generously included Kevin and me. Kevin Smith is another one of the organizers. This paper is really Anoop's project here and his colleagues at Merle. But it's a nice example of I think a challenge in this area of algorithmic reasoning, bringing together vision or image-based reasoning and language, and consists of a bunch of problems like the one that you see here, which comes from the Math Kangaroo challenge for like math contests for first and second graders, basically. But these are really nice examples of algorithmic reasoning problems that I think the cognitive AI community connecting vision and language can be thinking about. And you'll see a lot of other examples in these kinds of problems over the course of today. And I think it's really striking to see both what some of the most recent progress on these problems has been. The basic message of this paper that was just presented at CVPR just a few months ago is that basically machine learning approaches based on neural networks are not very good at most of these problems. But just very recently, we've been seeing things like GPT-4, which now takes in images. So here's what happens if you give this the teaser figure problem to Chat GPT-4. And actually, I should say, just sort of look at the problem just so you sort of see what's going on. So Bird Bobby jumps on a fence from the post on the left to the other end. Each jump takes him 4 seconds. He makes 4 jumps ahead and then 1 jump back. Then again, he makes 4 jumps ahead and 1 jump back, and so on. How many seconds? I'm hearing a bunch of sound. I'm not sure if, can you guys still hear me okay? Okay, I'm just going to keep talking unless somebody tells me that it's not working. So anyway, he goes 4 jumps ahead and 1 jump back, and each jump takes 4 seconds. So how long does it take him to get to the side? And you can sort of figure this out by just following this out. 1, 2, 3, 4 jumps, and then 1 jump back. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14 jumps, and each one takes him 4 seconds. So it's 14 times 4 is, what is that, 56. So C. And what happens when you give this to GPT-4? Well, it does really quite well. It actually gets the wrong answer. It derives 48, not 56 seconds. But it has almost exactly the right reasoning. Notice where the answer goes incorrect is that it's really in the vision here. So good for the ICCP community. It seems to correctly analyze the image in terms of birds and fence posts, and it really gets the basic idea, but it miscalculates the geometry. Okay, and again, we've seen many other kinds of things. This is a challenge for large pre-trained models, getting number, set, spatial relations, all the aspects of vision that really matter for reasoning is quite hard, still challenging. Okay. If we try, I mean, GPT-4 is again, really pretty remarkably good at reasoning. If we try BARD, this is just the latest version of BARD, it actually gets the right answer in terms of multiple choice, C, 56, but its reasoning is just completely off. If you look at this, it figures out, it does a bunch of calculations. I mean, it's sort of right, but then it calculates something which is 11.62 seconds, which is closest to answer choice C, 56. and that's not even closest to answer choice C. In fact, as I mentioned this, it says it's closest, it realizes it's answer choice 48. It apologizes for its mistake and still being under development. When I ask him how confident it is, Bard says, I'm very confident. And it explains what is, again, not a crazy logic, but it's way overconfident. And it's not, it's this, I want people to think, the reason why I'm dwelling on these examples a little bit is I'd like us to be thinking about what is really at stake in human reasoning. It isn't just analyzing it, in these cases, just analyzing an image, getting something out of it, and then seeing what language can unfold for you. Reasoning does require a sense of actually thinking about the problem that you're trying to solve, and whether if there's problems, where are the problems actually located? That also means like understanding, how the structure of the world that's somehow realized in either the language description or the image, like how those are actually about a world, and a sense that in your head you actually have to be constructing a little model of a world here and reasoning about what you know and what you don't know. So these issues of world modeling, certainty and uncertainty, those are key parts of reasoning that are not just about vision and not just about language. And I think the community needs to be thinking about. It's not only Bard that has trouble with overconfidence. So if we go back to GPT-4 and slightly change the prompt, just actually make it a little bit cleaner, we now get a different answer. And it's because it just has slightly I mean, the image is the same, but it's slightly miscounted again, a different number of fence posts. But now the number, unlike before when it miscounted and it got a wrong answer, that was still one of the multiple choices. This one isn't even a multiple choice. So GPT-4 says, well, maybe there's a mistake in the problem or the answer choices. And I said, well, how likely do you think it is that there's a mistake in the problem or answer choices versus your solution? And it goes and reanalyzes and says, nope, I'm definitely right. Definitely the answer choices aren't right. Okay. I said, I agree your mathematical reasoning is good here, but might there be another reason why you're getting the wrong answer? And it reanalyzes the problem, and then it changes its answer. Right before it was 52, now it changes it and it gets B, so it makes it worse. It's really there. It does seem like the things that we actually identify with human reasoning, which in this case also means being able to understand, like maybe it didn't count correctly. Okay. To try to simplify it, I re-simplified the drawing. I just drew 11 lines, and that doesn't seem to help. It gets a different number here. Now it thinks there's 7 gaps, and time is running short here on this intro, so I won't go through all the details. But it sort of gets the correct answer by mistake. But then when I ask it about whether its reasoning is right, it changes the answer. Again, it's not among the answers provided. I say, can you think of a reason your answer might not be correct? It says, nope, I definitely can't. There must be an error in the problem statement. I said, well, trust me, there's no error in the problem statement. Can you think of another reason you might be getting the wrong answer? And it thinks it again. And again, now this time it comes up with a different mathematical justification and changes its number again and convinces itself that, oh, it saw the oversight. So again, it's apologizing for its confusion, but it's, the confusion is just getting worse, not better here. So again, reasoning, and whether it's from vision language or vision and language, has to tackle the fundamental issues of certainty and uncertainty about your own knowledge and your world models that you're seeing kind of exposed here. I don't want to give any impression that these multimodal vision and language models, especially GPT-4, aren't remarkable things. I mean, it's really amazing. You can put in now any image. Like here, you can give it a map from a city, and it can parse the map, sort of. This is a made-up. I got this from a website that generates made-up cities, but with names, reasonable street names, and it seems to be able to read the street names. But if I ask for walking directions, again, it gives a bunch of things which it could in principle read off from the map. You could solve this problem. It's not even a hard reasoning problem, but again, it gives directions that don't actually work, leaves out most of the things, and most of these streets don't even connect, although they're sort of in one part of the scene. And again, it's very much it's somewhat overconfident. I mean, it's confident, but it shouldn't be at all confident. Or another sort of problem, one that Kevin and I and other colleagues have worked on, is like visual intuitive physics, like looking at these stacks of block towers. I'm not showing it here actually. Bard is pretty good at this, but GPT-4, if you look at this, I think most of us would agree. These are roughly ordered from stability. The one on the left is like a little, on the edge, but probably stable. This one, maybe this top block will fall off, but kind of fairly stable. This is pretty unstable, and this one is very unstable. And let's just say GPT-4 is not getting that. In contrast, that again, many of you might be familiar with the kind of models that we've built. Also, Jajun, one of the invited speakers, has worked on similar things actually back when he was a PhD student long ago with us at MIT. And you'll see, I think, some of the cool latest developments from him coming up here. But the idea that people might construct in their head a mental simulation, something like a game physics style representation, like a simplified, approximate, but very efficient representation of physical interactions that you can run a few mental simulations on. And this is a very powerful way to do a lot of reasoning, where the visual image sets up this world model. And in some recent work that we've been doing in our group, led by Said Zhang, also with Leo Wang and Gabe Grand, in a recent CogSci paper, this is just an example of showing how you can take a language model that writes code that can interact with one of these mental physics simulators, which is just one example, I think, of exciting things we can do that aren't just a single big pre-trained model, but looking at models that combine modular components for how language and vision might connect through symbolic representations of worlds and probabilistic representations of uncertainty. And again, I think you'll excuse me, you'll see examples of some of these kinds of models and many other things that the community is exploring that I think is just really exciting place for research in AI, but also drawing on some of the cognitive science work that, like, you'll hear from Elizabeth Spelke, and some of the cognitive AI challenges that Francois has put out, and just the various computer vision and embodied intelligence perspectives from Jitendra and Anima, and then all the many contributed presentations. So it's really exciting day. Again, I wish I could be there in person. I'll look forward to seeing the talks and interacting with more of you soon, I hope. Thanks.